13,500 tons of steel that devours 250,000 tons of earth every single day and then walks. In 1978, Krupp spent $100 million building Bagger 288, the largest land vehicle ever to exist. It was engineered to never be taken apart. And that single decision would create one of the most extraordinary logistical challenges in engineering history. Krupp's commitment to Bagger 288 began in 1972, when the company signed a contract worth $100 million, an amount that would reach over $400 million in today's money. The project demanded 5 years of continuous work, drawing on the resources of Germany's largest industrial firm. At its core, the challenge was simple to state but daunting to realize: to build a machine that could move more earth in a day than any other land vehicle, and to do it without the option of ever taking it apart. The finished excavator stretched to 225 meters in length and stood 96 meters tall, a silhouette that dwarfed every structure in sight. Weighing in at 13,500 metric tons, it outweighed the ironwork of the Eiffel Tower. The sheer scale of the machine required thousands of tons of high-strength steel, a workforce that peaked at over 1,000, and a supply chain that spanned the continent. Every decision, from the welded chassis to the integrated power systems, reflected the scale of the financial and engineering gamble. For Krupp, the investment was more than a contract. It was a statement of what industrial ambition could look like when limits were pushed to the edge of possibility. Dominating the front of Bagger 288 is its immense bucket wheel, an engineering centerpiece that transforms sheer size into relentless productivity. The wheel itself measures 21.6 meters across, nearly the height of a 7-story building. Arrayed around its rim are 18 steel buckets, each shaped to carve and scoop as the wheel turns. Every bucket can hold 6.6 cubic meters of earth, enough to fill a large pickup truck in a single pass. As the wheel rotates, these buckets dig into the overburden, filling and emptying in a continuous rhythm. Over the course of a single day, this system moves up to 240,000 tons of material, an amount that would take thousands of dump trucks to haul. The geometry of the wheel, the spacing of the buckets, and the precise angle at which each one bites into the ground are all calculated for maximum efficiency. This is not just brute force, it is a carefully balanced machine, engineered to strip away layers of earth at a pace that matches the demands of modern mining. Every revolution of the wheel is a display of industrial power, translating massive dimensions into the raw power needed to reshape the landscape. Bagger 288 does not roll on wheels. Instead, it moves on a set of 12 crawler tracks, 6 on each side, stretching nearly the full length of its undercarriage. Each track module is about 3 meters wide and 12 meters long, arranged in staggered pairs to keep the machine balanced as it creeps forward. This design spreads the excavator's 13,500 tons over roughly 8,000 square meters, keeping ground pressure down to just under 25 pounds per square inch, comparable to the footprint of a human walking across soft earth. The result is a behemoth that can cross overburden, clay, and even reinforced roads without sinking or leaving deep scars behind. Movement is slow, almost hypnotic. At top speed, Bagger 288 advances just half a kilometer per hour, covering less ground in a day than most people walk before breakfast. But this deliberate crawl is by design. The 12-track system not only protects the ground, it also provides redundancy, so if one track fails, the others keep the machine moving. It's a paradox of scale, a land vehicle the size of a city block, engineered to move with the patience of geology itself. Hambach, in the heart of North Rhine-Westphalia, is not just another open-pit mine. It's the site of one of Europe's richest lignite seams, buried beneath thick layers of sand and clay. Before a single ton of coal can be burned for electricity, all that overburden, sometimes more than 200 meters deep, must be stripped away, day after day, without pause. That's where Bagger 288 comes in. The excavator was built for a single, relentless task: exposing lignite at a pace that kept Germany's power plants running. Its bucket wheel doesn't just dig, it feeds a network of conveyor belts stretching for kilometers, moving the earth directly from the pit to the spoil heaps, with hardly a human hand touching the material. For Rheinbronn, and later RWE, the uninterrupted flow of overburden was a matter of economic survival. If the digging stopped, conveyor lines would idle, power stations would burn through reserves, and the cost of interruption would ripple through the entire energy sector. In this setting, Bagger 288 wasn't just a machine, it was a linchpin in the region's energy supply chain, engineered to operate around the clock, in all weather, for decades on end. In May 2001, Bagger 288 began a journey few machines could survive, a 22-kilometer relocation across the German countryside, completed without ever coming apart. For 3 weeks, the excavator advanced at a deliberate crawl, averaging just over 100 meters per day. Each meter demanded careful planning. Civil engineers worked ahead of the machine, clearing its path and reinforcing the ground beneath the 13,500-ton load. The route crossed highways, rivers, and even the edge of a small village. The most dramatic obstacle was the A44 Autobahn. Transport authorities issued a special permit, closing the highway and laying down a temporary steel platform, strong enough to bear the full weight of the excavator. Traffic was rerouted for 2 days, while teams monitored every centimeter of the crossing. Elsewhere, power lines were taken down and reinstalled, and 2 farm bridges were rebuilt with composite decks to handle the pressure. In the village of Mulson, streets were shut and residents evacuated as the machine rolled past on reinforced mats. The entire operation became a moving spectacle of logistics, engineering, and public coordination. It was proof that for Bagger 288, the only real limit to mobility is the landscape itself. Disassembling Bagger 288 was never a real option. The entire frame is a web of welded steel, each joint heat-treated to handle the immense forces at play. These welds are not just seams, they're permanent bonds created under precise conditions that cannot be replicated in the field. Breaking them would mean losing the original strength and risking fatigue cracks that threaten the entire structure. For the engineers who designed Bagger 288, permanence was a feature, not a flaw. Even if engineers tried, every major component would need to be cut free, loaded onto specialist cranes, and then re-welded and recertified to exacting standards, an undertaking as complex as building a new machine from scratch. Economically, the numbers are stark. A full disassembly and reassembly would cost as much or more than constructing a replacement. The logistics alone, from sourcing enough heavy-lift cranes to finding space for reassembly, would stretch resources beyond reason. The only practical way to move such a machine is as a single, unified whole, preserving the integrity of every weld and the value of every hour spent in its original construction. Bagger 288's reign as the world's heaviest land vehicle would not last forever. In 1995, its direct descendant, Bagger 293, rolled out of the Krupp assembly halls, carrying the lessons of its predecessor into a new era of mining. The changes were evolutionary, not radical. Bagger 293 added weight, tipping the scales at 14,200 metric tons, about 700 more than Bagger 288. Its daily excavation capacity climbed as well, reaching up to 290,000 tons per day, a gain of 50,000 tons over the original. The 12-track system remained, but each track module was widened and reinforced, spreading the machine's mass even further to reduce ground pressure. The bucket wheel grew only slightly, but refinements in the conveyor and drive systems allowed for steadier, more efficient operation. These incremental advances reflected a philosophy of relentless improvement, not to outdo the past with spectacle, but to build on it, pushing the boundaries of what a single machine could accomplish in the world's largest open pits. Germany's plan to exit coal by 2038 has brought new questions about the fate of machines like Bagger 288. Preservationists argue that the excavator stands as an irreplaceable artifact of industrial heritage, a monument to the era when engineering ambition reshaped entire landscapes. Local communities see both the legacy and the burden. The machine is a source of regional pride, but also a reminder of jobs lost and land transformed. Energy firms, facing the costs of decommissioning, weigh the technical reality that Bagger 288 cannot be dismantled and rebuilt without destroying its integrity. The welded frame, the scale of its components, and the logistics of moving such a structure make any relocation or preservation effort a costly proposition. Heritage advocates propose turning the machine into a museum piece, while others push for full dismantling to reclaim the land. Each option comes with its own financial and technical hurdles, and no consensus has been reached. As the 2038 deadline approaches, the ultimate fate of Bagger 288 remains unsettled, a symbol caught between preservation and practicality and the changing values of a country in transition. Today, Bagger 288 still carves earth for German energy. Its scale is now questioned in an era demanding cleaner solutions. As engineering chases ever bigger feats, the world must weigh progress against consequences. The true legacy of giants like this is not just size, it is the questions we are still forced to ask.